Hi everyone, my name is Preeti. Pursuing my education in Sri Venkateshwara College of Engineering, Bangalore. So this is a principle of communication system. So now we'll see about frequency division multiplexing. So introduction to frequency division multiplexing. In this, a technique used in a telecommunications to transmit multiple signals simultaneously over a signal communications channel. It works by dividing the available frequency band into a smaller subbands, each carrying a different signals. In this, it will divide a subband into smaller bands, each carrying a different signals. So the frequency division multiplexing, it is a one used technique which communications to transmit the signal simultaneously. So next we'll learn about principles of function division multiplexing. In that we have the three FDMs principles. We'll see first one frequency separation, second one simultaneously transmission, third one demodulations. In a frequency separations, a single of assign a unique frequency band separated by the guard bands to private interference. In a simultaneously transmissions, multiple signals can be transmitted simultaneously, so over the same communication channel by using different frequency band in a simultaneous transmissions. And next, demodulations. In that, receiver and the individual signals are demodulated and extract from the composite signals using filters. So next we'll see advantage of FDM. So first one is efficiency spectrum utilized in FDM allows from the simultaneously use of the same frequency spectrum by multiple users, improving overall bandwidth efficiency. Second one, flexibility. So in this can accommodate a wide range signal type and data rates, make it versatile and various applications in a FDM. So we can accommodate the wide range of the signal types and data rates, make it versatile various applications in the same frequency spectrum by multiple users to improving the overall bandwidth efficiency, which allows the simultaneously to the FDM and utilize the uses of bandwidth between frequency challenge helps to minimize the interference between signals, which helps the signals to guide bands between the frequency channels, and FDM allows the simultaneously and even the frequency spectrums, it multiple the different types of users, which improves the bandwidth in a FDM. So next we'll see bandwidth allocations in a FDM. Dedicated frequency bands in a FDM, each single is assigned a dedicated frequency band, ensuring that they do not overlap each other, interfere with the bandwidth allocations in FDM. So next one, dynamic allocations. Some dynamic allocations in a FDM system can be dynamically allocated frequency bands based on the varying bandwidth needs of the different users and the applications in a bandwidth allocations. So next one, grind bands, which are space between the frequency bands, helps to prevent signal leakage and interference between adjust channels in a bandwidth allocations. So these three are the bandwidth allocations in a FDM. So next we'll see modulation techniques in a FDM. So there are four different types of modulations techniques in a FDM. First one, amplitude modulations, frequency modulations, phase modulation, quencher amplitude modulation. So first one, amplitude modulation is used to encode informations by varying amplitude of the carrier signals. So second one's frequency modulations is used to encode informations by varying the frequency of the carrier signals. Third one, phase modulations, which used to encode information by varying the phase of the carrier signals. So third one is a QAM combinates with amplitude and the phase modulations increase efficiency in the modulation techniques in a FDM. So next, challenges and limitations of FDM. spectrum scarcity, wideband overhead, complexity and frequency synchronizations. So next we'll see the spectrum scarcity. In a limited availability of frequency spectrums can we limit the numbers of the challenge that can be supported by the FDM. So grand band overhead, which uses a bands reduce the overall spectral efficiency has a portions of the bandwidth is unused. So frequency synchronizations, which frequency is required to prevent signal interference and ensure accurate demodulations. Next, complexity, which in a FDM system can be used more complex to the design and implement compared to other multiplexing techniques in a FDM. So next, applications of FDM. First one is broadcast radio and TV, which in FDM is used to transmit multiple radio and television channels simultaneously over the same frequency band, which uses the same frequency band like a multiple radios and television channels which over the same frequency band which used to broadcast the radio and TV in the FDM. So next, satellite communications, which used to allocate different frequency band to multiple satellite channels and enabling efficiency spectrum utilization, which use the different types of frequency band in a multiple satellite, which communicate the efficiency spectrums utilizations in a FDM. So wireless network. FDM is used in a Wi-Fi, cellular networks and other wireless enables multiple users to access the same frequency band in a FDM. So these are the applications of the FDM which use the different types of radio communication satellites and wireless networks. So next we'll see trends and development in FDM. So spectrum efficiency modulations, which advancement in a modulation techniques such as higher order QAM can be improve the spectral efficiency in a FDM system. Second one, dynamic bandwidth allocations, which intelligent algorithms of the dynamic frequency band allocations can optimize the uses of available spectrum in a FDM. So integrations with other technologies which uses in a FDM likely integrated with the emerging technologies like 5G, LOT and convertive radios enhance overall the performance systems in a future trends and development in FDNC. Thank you.